We are going to start looking at objects in detail and how to introduce more abstraction into our own programs by extending the basic Python objects with our own objects using classes. And this represents an introduction to another kind of style or paradigm of programming than what we've primarily been working with. So before we dive into the details, let's get a little philosophical. And so I like this, what I call a Greek view of object-oriented programming. So Python was the name of the dragon killed by Apollo at Delphi. And so as a Greekophile, it's always fun to look at what the ancient Greeks would say about our programming. So after killing the Python, Apollo built a temple at Delphi, and the temple was graced with two famous inscriptions. The first was nothing in excess, and know thyself. So we're going to look at these two inscriptions as a guide to how we should approach object-oriented programming. So first off, nothing in excess. So Python takes a pragmatic approach to object-oriented programming. So object-oriented programming is good for lots of things like computer graphics, but for many scientific programs, traditional procedural programming is a better fit. Or now with the rise of massively parallel computing architectures, functional programming is a paradigm that should be of interest to us. Python lets you write programs that best fit the nature of the problem. Some things work better than others in Python, so Python supports functional programming, for example, but it's not really geared towards it. And in Python, everything is an object, and so in that sense, it's a purely object-oriented programming language. But what it asks of you is flexible, so it allows you to write traditional imperative programs. It also lets you write object-oriented programming. And so we can use classes to extend the types of objects that are available in Python when needed, but we don't need to do it in excess. We don't have to write object-oriented programs. And what we'll find as we get more experience with the language is when we think of writing a class, we might find oftentimes that just using a built-in dictionary class would be fine. Okay, the second inscription, know thyself, brings to mind one of my favorite definitions of an object. And this comes from Mark Thomason, who is a former student that unfortunately died of renal cancer a few years ago, a former biomedical informatics student, and there's a scholarship and there's a lectureship in his honor now. So Mark would always say that an object is an object that is something that knows itself. It knows how to print itself. It knows how to read itself from file. So the object knows how to do all the basic functions associated with it. For example, an image should know how to read its data from disk or write itself to disk. A list object knows how to print itself, how to insert an object into itself, how to sort its components, etc. When we say that an object knows how to do something, we mean it has a method that performs that function. So a method, and we've been using these, and I've been using the word function interchangeably. So if we could think about a string object and we talk about find, find is a method that is attached to that object. So a method is kind of a specialized function. So other characteristics of objects that be important for us to keep in mind are polymorphism, from the Greek meaning having multiple form. This allows you to write programs of similar form regardless of the underlying representation nature of the object. So polymorphism allows you to call the methods of an object without knowing its class or type of object. So we can call length, without knowing whether we're passing to it a list, a string, or a tuple. So that's an example of polymorphism. Other important ideas are encapsulation. So encapsulation is the principle of hiding unnecessary details from the rest of the world. And encapsulation enables you to use the object without worrying how it's constructed. What this means is you provide to the user of your object an interface that hides from them the details of how the underlying data, for example, is stored. So that if I have underneath in my class, I have a list as a basic collection type and I want to switch it to a dictionary, that the user of my class can be oblivious to that change because they are interacting through they're not directly accessing this underlying data, they are accessing it through methods that are defined with the object. So that's essentially what we mean by encapsulation. And then inheritance. Groups of objects have similar characteristics, and so in object-oriented programming we'll define a kind of a top-level object that defines kind of the common characteristics of all these classes, and then we will define inherited classes that add or modify characteristics. So an example of this might be shape. So we might have a general class that's shape, 2D shape, and it comes with the concept of area or perimeter. We might inherit from that the idea of an object, a class object, a circle object, which replaces the more generic concept of perimeter with a more specific concept of circumference. We might add to it a polygon, which is a 2D shape and it has area and perimeter, but it has an additional concept of the number of vertices that define the polygon, and so on. And what we'll do later is look at how could we define classes that represent a person, and from a person can we derive inherited classes that are patients and maybe providers. And from a patient, could we have an inherited classes like an ICU patient or an inpatient or an outpatient? So these are the kind of questions that we're going to be thinking of as we work through defining classes. Okay, so as I've hinted at, there are a variety of programming paradigms, and we've largely been working in what is referred to as an imperative paradigm. But all along we've been making use of Python's underlying object-oriented nature. So all intrinsic types in Python are objects. An integer is an object, and objects have attributes, which we might think of as adjectives, and they also have methods, which we might think of as verbs or functions. So this is not working well here, but if I come up here, so what I've done is I've defined a variable, a number equal to 1, and then I'm going to do the help on that. And so here it's an integer object, and this is listing different methods. So it has a method. This double underscore is going to be what's often referred to as magic methods that provide common functionality between different types of objects. So this is a comparison function, a coercion function, and so on. So that our simple number, 1, has all these attributes and methods associated with it. We can do the same thing with a string, where we can look at, these are the methods that are associated with that string, and we can look at kind of the hidden methods. So these are different, mostly methods that are associated with this string object. Okay, so classes are how we extend the kind of objects that are available to us in our programs. So a class is how Python allows us to extend the basic objects in Python by creating new objects. And since objects consist of attributes and methods, as I mentioned, defining a class means defining the attributes or the characteristics of this class and the methods that will be called or evoked to manipulate it or return values from it, etc. So a class is defined with a code block and the keyword class. So a code block, just let me fix my typo here. So just like our while statements, our for statements, our if statements, our functions, so we start with the keyword class. we provide a class name, and then our classes are always going to inherit from some more basic class. And we do that with these parentheses, and then the class that we're going to inherit from, close parentheses, the colon to mark the beginning of the code block, and then an indented collection of statements that represent the body of the class. So all classes must inherit from some more basic class. I'll have a note about this in a second. And the most basic class in Python is called object. Classes in Python are, according to the developer, the creator of it, Guido van Rossum, an afterthought. And so the initial implementation of classes had some problems with it, so a new style class was introduced in Python 2.2, and that's what we're going to be using. But if you look at the Python official documentation, it has that all caught up to represent the new Python class style. And so you'll see differences between what I'm showing you and what you will see in the documentation. And this is primarily that old style classes do not have to inherit from a previous class type, such as object, and they have a different functionality for evoking parent class functions. Okay, so let's start off by working through an example of defining a pet, a class for describing pets that are in an animal shelter. So so we start off, we have our keyword class. We have the class name that we're going to use, shelter animal. And in this case, we are going to inherit from object. And then we have our open parentheses. And what I'm going to do is I'm going to start off by defining a constructor. And this is a special function that's always denoted by this double underscore and a double underscore name. And this is the function or the method that is always called by Python when this class is instantiated. So methods of functions take a special first positional argument that is traditionally called self. It doesn't have to be called self. You can use any variable name, but the traditional usage is self. And then a list of other variables that would come in to the constructor. In this case, we're going to use keyword argument species, which will default to dog, an age, which will default to 0, a name, etc. And so then in this constructor, we're going to take this variable self, which represents a particular shelter animal instance, and initialize a bunch of attributes. So these are our adjectives. So the species, the age, the sex, the name, the ID, the altered status, a list that would represent the problems associated with this animal, medical clearance, and then a string for comments. So these are our attributes. And then we're going to define methods or verbs. In this case, I'm going to define methods for setting the pet name and getting or returning the pet name. And then an additional function for adding problems, where I take a problem and I append it to my list that is stored here in self.problems. Okay, let me make some comments here. Whoop. And I have a slide about this later, which we'll probably skip over. But why would I use this function set name, where all I'm doing is taking a variable name and I'm assigning it to self.name? Why don't I just directly access self.name? Well, this goes to the idea of encapsulation, that I want to hide the underlying details of the representation from the user. And there's a couple of reasons for this. First off, I can change my underlying representation without the user having to change their program. I can also do things like validation. So if I had, for instance, a set ID, and in my shelter there were particular constraints on what an ID could be, like it could only contain alphanumeric characters, then in my set name I could do a validation that this is truly a valid ID. instead of before I directly set it. If it's not, I would return an error message, etc. to the user. So this allows me to do validation and hide my underlying representation from the user. Okay, so let's do a function adopt match. And what we're going to do here is I'm going to pass in a bunch of features that would be issues related to like the person that wants to adopt the animal. And if any of the, like say they have a cat, and so if any of the issues they have here are in the problems list of the particular animal, then this will return a false, that this is not a valid adoption match. If none of the features or issues that the adopter has are problems for the adoptee, then it will return true. Okay, and this is again addressing the question, why not address the access self problems? That we don't want the user to have to know how problems are represented in our code. Okay, so how do we go about creating an instance of the class? So an instance of the class or objects is created by invoking the class name followed by parentheses and any arguments that constructor that we defined might contain. So in this case, I'm creating a shelter animal named Rob, and it's just going to use the default values that were defined in our class. So it'll be a dog, it'll have age 0, it won't have a name, etc. Okay, that is how we create an instance of an object that we've defined with a class. Okay, so now I want to look at making a more complex adoption matching algorithm. So I'm going to define a new method, which I call adoption match 2, and it's a method of this class, so it always takes this first argument self, and it's going to take a list of features. And the first thing I do is I just call my original adoption match function, and I want to, in addition to making sure that there aren't any problem matches between the adoptee and the adopter, I want to make sure that first the animal has medical clearance, that it's already been altered, and that its age is greater than my minimal adoption age. And if all these conditions are matched, then it returns true, else it returns false. A note to kind of highlight here, you see that when we are calling the adoption match function, we are only passing the argument features. But if we look up to how that method was defined, you see it has a first argument that is self. Self is always passed implicitly. We do not pass self to the method call when we are calling it from our functions. So that's something that people get hung up on a few times. Okay, so here's our new shelter animal class where we've added this the second adoption match method. Again, just emphasizing that point. Okay, so now we can create a new object, new instance, Randy, and a shelter animal. Now I'm passing in default. I'm passing in keyword arguments and replacing some of the default values with my own values. So this will be a dog. This will be, I don't know if I have probably 3 weeks or 3 months. We don't specify what units or what the age, sex, a new name, an ID, and an altered status. And then I'm printing it out. And you see that when we print it, I get this kind of not very meaningful print output that in my module main, I have the shelter animal object, and this is a memory location. And we will learn how to define new methods that are invoked when a print statement is used so that we customize how our classes look when they are printed. Okay, so I can add problems to Randy. I can say that Randy doesn't like cats. He has a hip problem. And now I can see if there is an adoption match if we have a person that has birds and cheese, whatever. In this case, if I do the adoption match, I get a true because neither of these issues are on the problems for Randy. But if I do the adoption match too, I get a match value of false, and that's because it's not old enough or medical clearance hasn't been achieved, etc. Okay, so I can create a new animal, Argos, and see again I can add a problem to him, and add problem as a method. A method is a kind of a function. A function always returns a value. If I don't specify the value, it returns a none. That's why I get a none here. And then I'm going to check and see if there's an adoption match. And it's false, and I imagine that's because medical clearance hasn't been set. Okay, I got to figure out how to make these screens. So this is a new class. This is defining a class for a person. Oh, come on. Where the beginning of our screen is cut off. But we have a constructor, takes first name, last name, middle name, doing different things here. I'm going to have a method get full name, which returns a string, which is combining first name, middle name, and last name. I'm going to have define this method get characteristics, that is taking our names, sex, and age, and putting that into a string that's returned. Okay, so this is just our basic class. Let's see if I stretch this down some. There we go. Okay, now my navigation screen is outside of the screen capture, but that should be less important. So the way we would define an inherited class, in this case patient, is it now, instead of inheriting from object, inherits from person. And then I proceed very similar to how I worked with defining my initial class, person. So I use my keyword class. I have my colon that marks the beginning of the code block, and I'm defining a constructor. And this is all very similar, but in my constructor I'm going to invoke a function called super, and this is what I'm going to use to call all the chain of constructors up the inherited path for patient. And so in this case I provide the class, the current class name patient, and the argument self, kind of a inconsistency here in how we are using self, and then dot and the parent function that I want to invoke. In this case I'm going to invoke the constructor for person and pass to it the arguments that are associated with the constructor of the person. And then I'm going on and doing I'm instantiating the attributes of a patient that are specific to patient and not part of person, such as the primary care provider, the chief complaint, medical record number, etc. Okay, and now I have a get characteristics similar to what I had in the person. In this case, I invoke the super method and this will evoke all the get characteristic functions that are defined up the inheritance chain. So in this case, it will invoke it for a person, and that will return a string, and then I'm going to add to that string that's returned from person the characteristics of a patient, the PCP, chief complaint, medical record number, etc. Okay, so in this case, I'm defining a person representing me. And then I can get the characteristics, if I can print them. And now I'm going to define a patient Brian, which is, I have the same things. I have a name, I have an age, sex, but now I have a primary care physician, a chief complaint, and a medical record number. And I can, now if I print patient Brian get characteristics and print Brian get characteristics, you can see that I'm getting this string for the person, and then when I'm doing the string for the patient, I'm getting essentially the same thing with these additional characteristics added into the string. Okay, so that's our basics on defining classes and creating instances of those classes. Python comes with a couple of utility functions that help us work with classes. So we can there's an is subclass method and is an instance method, and these will take an object and we can ask, is this an instance of a person? Is this a subclass of a patient, etc. So in this case, I can see, so I'm asking, is a person a patient? False. A patient is a subclass of person, which is value. It's true on the next line. Is Brian a person? Yes. Is patient Brian a person? True, because a patient is a kind of a person. Is Brian a patient? That's false. Is patient Brian a patient? So is this an instance of patient? And that is true. Okay, our last topic is kind of something I haven't used very much, but we've been creating, with our constructor, we've been assigning attributes and attributes to a particular instance of a class, but classes can also have class level variables. In this case, I'm creating an object, a class class1, and you see here's my constructor, similar to what I did with the pet animal. But I have this variable that's on this, that's just at the top level of the class, and I'm calling global1, and I'm setting equal to 1. And now I'm going to mess around with something. So first off, I'm going to create a class, one instance that I'm calling C1, and then I'm creating a class, a C2, another instance of class 1. And we are going to ask what the value of the class1.global variable is. And you see initially we have just the class1 global 1 value is 1, and both C1 and C2 have access to that class value, global 1, and I can print out and it's 1. Now I come down here, I'm going to do the statement C2.global1 equals 3. And now I'm going to print so what C1 global 1 is equal to. You see it is still equal to 1, but now C2.global1, I print it, and it is equal to 3, which is what I set to here. So essentially, they're not referencing the same thing anymore. So I've now created a variable in C2 global 1 that is hiding the class 1 global 1 value within that instance. When I change the class 1 global 1 value to 5, and then I print things out so I see that C2, it still has a value of 3. So I'm not changing it. It's referring to a completely different variable now. Class 1 global 1 now has a value of 5, as does C1 global 1, which is referencing that class level variable. But the C2 global 1 variable still has the value 3.